Hi, everybody. Oh, that really works pretty well. I want to thank you all for coming to the Front End Summit, and especially coming to my presentation. I really like looking out there and seeing a lot of friendly faces, so it's really pretty cool. Before I get started, I want to take a chance and say thank you to everyone that has spent their time to plan this event and to volunteer at the event. So let's go ahead and stop and just give everyone some love. I appreciate it. So, as you're already familiar, my name is Seeley. I'm a front-end engineer on the Yahoo front page. And I'm here today to talk to you about the tablet version of Yahoo front page. So the first thing that's important to start off with when talking about the tablet front page is why did we build the tablet front page? It really comes down to the fact that last year iPads were selling like crazy. Each quarter, more and more iPads are getting sold. What this really works out to is more and more users. More and more people can be invited to use Yahoo products on a new device. And to make matters more interesting, as we started to consider when to make Yahoo.com tablet friendly, we noticed that the tablet sales for the holidays were expected to be very, very large. It was supposed to be the Christmas of the iPad. So it was about November, and we're looking at it and we kind of go, oh my gosh, are we ready for Christmas? And the answer was kinda. The page renders fine on the iPad, or rendered fine on the iPad. But as you can see, it's still a desktop page. When we look at the Today module over here on the side, we can see that from a mouse point of view, it's okay. The text is small, but it's easy to touch with a mouse. When users on desktops hover above these boxes, we give them a nice preview of the story that's available there. As we all know, hover is not available on tablet devices. So all these tablet users coming in, they really don't get a good chance to interact with the content on the page. Not just that, but we weren't doing a great job presenting the content and laying it out. You can see that we have a lot of dead space here. We can also see we have a giant flipping ad on the page too. This takes up as much space as the Today module, which, while that might be good for us and for our pockets, that's not going to bring users back to the page. So we put together a small team, and in a couple of weeks we went ahead and we turned this around. Now you see it has a lot of the same elements that were on the original desktop page, but it's very much focused on the device. You can see the Today module is now huge. Users can touch it with their fingers and preview additional stories. They're no longer limited to just picking the first story and hoping it works. We're presenting very rich media, and the size of this graphic is undeniable. You come in, and it gives you a really good first impression of Yahoo's front page. This is Yahoo. This is the kind of experience that we want our users to have on our front page and inside the network. You'll also notice we are serving an ad on this page, but we're not serving the F ad. We're serving an ad that fits into the experience. It's not cluttered, it's not distracting, and it gives the ad people a chance to sell something new, to really define the experience that they want to make for the users also. So we were really fortunate to have the ability to redefine certain things like the ads or the size of the page. Now, when we first launched the page, it was just for iPads. That was the only tablet device that was interesting enough as far as users and capabilities to warrant us taking time to build the page. But as we all know, Android tablet sales have been increasing, especially with the Galaxy tablet as being one of the first viable Android tablets to be released to the US market. So we started to bring in support for the Galaxy tablet. Now characteristically, it's not just the Galaxy tab itself, it's the size of the tablet which is interesting to us. So we'll get more into that later. So the good news is, coming from a desktop web development background, is that most of the skills which we already know translate very well to developing on the tablet. It really isn't that far of a reach to building a website for your desktop browser and then hoping that it looks well in a tablet device. But not everything is cut and dry. For instance, the Today module implementation, we had to take a lot of care with that. That is the first impression on the page. It was very important to us to really nail it. The second thing that was unique was custom font face support. Now, I'm sure most of us are familiar with what custom font faces are, but we don't get a lot of chances to use them. But with tablet devices, we have a smaller set of user agents, which gives us greater flexibility for doing our CSS. And the last one is the viewports. The viewport, to me, is the most exciting part of building on the tablet. Really, on the desktop, we've gotten very cozy with the monitor. It's always 1024 by 768 or larger. It doesn't really get smaller. It doesn't change orientation. This, on tablet devices, do both of those. They change size, they change orientation. How do we fit that? How are we responsive to the device? So the first thing that we're going to talk about is the Today module. Now, first, right off the bat, you look at this, and it is gorgeous. It is huge. We give users the ability to see a nice title, see a rich font face. We use tricks like opacity and rounded corners to pull out the circle dots at the bottom. Now, this isn't automatic. As we can see from looking at this, just at the dots, that there's up to 10 possible stories to load there. That's 10 of those images. Those images are big, but really, really big. They're over 1,000 pixels wide, about 400 pixels tall. So what's important to us, as we try to deliver the best first impression, is to do it in a way that performs fast over the network, whether it's a slow connection or a fast connection, and is kind to the device. We can't possibly hammer any tablet or any device, in that matter, even a desktop browser, with 10 of these images all in succession and say, take it. It just doesn't work that way. So part of pulling this off is being very simple-minded about it, using simple markup, simple JavaScript. And CSS is actually fun, but keep it simple. So as the page loads, we load a structure that looks very similar to this. Now, first thing you notice, or hopefully one of the first things you notice, is the fact that there are no image elements anywhere in here. But we do have URLs as custom data attributes on the outer div. What this allows us to do is lazy load all the images. Now, we lazy load the images in response to the page load event and in response to events coming off of the outer scroll view. So as a user swipes this way or swipes that way, we catch an event. And that event is then used to figure out where the user is and what we should progressively load or unload behind them. Now, unloading is a big deal. If there's one thing I want you to take away, is unloading is a big deal. In the beginning, when we first built the module, we had a different implementation. We had a heavier implementation. We had a more sophisticated DOM. We had more sophisticated JavaScript. And we saw a lot of random crashes. Anytime a user was on, anytime is an exaggeration, frequently when users would be interacting with the Today module, it would just crash. All of a sudden, you're staring back at your iPad desktop. That is clearly the wrong first impression to send. So the first step we did, we simplified the implementation. So simple markup deserves simple JavaScript as well. This is it's a small example of the JavaScript that we use for loading and unloading the images. So you can see here, when we pass in an index, that lets us find the story, and then the image which we have to load. Then we go ahead and we just set it as an inline style, as a background image. Now remember, those images are huge. They're 1024 by 400. Our available real estate is not that large. So what do? Do we crop the image? Do we just let the image blow out the side over there? No. The answer is we use background size. Background size is a CSS property that we don't get a lot of chances to use on the desktop. But what this allows us to do is essentially mimic what you could do with an image with 100% width and 100% height. But we don't have to use an image for this. We just use background size. We use a background image. Fewer DOM nodes, smaller CSS, simple implementation. Now, one thing I did that goes a little against our common practices of externalizing our JavaScript is I left all this JavaScript in the page right under the Today module. I did that for two reasons. One is so it's there on page view. But more importantly, the second one is if you want people to adopt your widgets, if you want them to copy paste your implementations and see how you did things, you need to make it easy for them. So if you're curious and you want to see how we built this and see all the functions that go into it, go ahead and just use source. Use source was my best friend learning front-end development, and I think a lot of us can still get a chance to use that to our advantage. So, remember when I said that when we load the page, there are no image elements? We use JavaScript to set all the images for us. That introduces a case where we have to handle fallback. Now, we like to assume that most of the user agents that come to this page will have JavaScript enabled. But with a high-profile site like this, we can't assume anything. We need to offer fallback for the different cases which we can handle. So fallback in this case is extremely simple. You take that markup which we're already familiar with, we wrap it in a no-script block, and instead of using a custom attribute that has the URL for the image, we just take that URL and we assign it directly to a background image style. Simple, right? The inline style might freak some people out, but at the end of the day, it gets the job done in a very performant manner. Now, simple matters. Steve Siders last year jumped over to mobile performance. When he did that, one of the first things he did was take a set of bookmarklets out there and browse the top 11 sites on the internet that have iPad, desktop, and iPhone versions. Now, when we built the iPad version, we were lucky. We had one beefy page to build that didn't have to share a lot of resources with our desktop version or the iPhone version. We could build it standalone all by itself. And just like I keep hammering home, we built it simply. And that really shows here. We have very few requests. We have very few HTML elements. And our overall body response size is small. And we need to be small. We need to use the network as little as possible because these devices aren't as beefy as our laptops. So that brings us to the second thing I want to talk about a little bit, is custom font face. Now, when I was a designer, custom font face was awesome. I always wanted to use it. I wanted a chance to use high-fidelity fonts in my designs. I got tired of using Arial. Verdana was the devil to me. So for years, we kind of languished in the fact that we could use it in some browsers, but we couldn't use it in all browsers. So as we started building this, we realized we can use it in these browsers. And we support one browser at launch, mobile Safari and iPad. And now we support a second browser, Android WebKit, on the Galaxy app. But I have to be honest with you. As an engineer, I don't like font faces anymore. I really don't. Now, first thing to keep in mind is when you're supporting font face on these two devices, you have two different formats of fonts to support. You have SVG fonts for the iPad, you have TrueType for the Android WebKit. Now, it's interesting to keep in mind that WebKit on the desktop, Chrome, Safari, and such, they all support TrueType, but not mobile Safari. So remember this, WebKit is a renderer. It has some embellishments on the outside, but it's a renderer. People can adopt that renderer inside of a browser implementation. Not all the features between all these browsers that use WebKit renderers will be the same. So this is your first warning. You have different fonts, formats to support. Now, using this in CSS is really straightforward. First thing you do is define your font face block. Then inside that block, you give the font family a name. And then you define whether it's bold or italic. Pretty standard stuff. The part that gets interesting is when we get down to the source attribute, source prompt. Now there, the font face rules have been extended to allow multiple formats to be supplied there. And each format has a URL associated with it. Or more correctly, each URL has a format hint, which is optional for it. If the browser does not understand the first format hint, it'll go on to the next format hint and get that URL out of it. So this is all you need to do to use custom fonts. The problem is, this isn't really the approach that any of us should use ever. The first reason is that fonts are late loading resources. This is the tablet version of Yahoo.com early in our launch cycle over a slow connection. So you can see this is on the iPad. It's downloading an SVG font, but it doesn't request that SVG font until the first time that an element in the DOM is encountered that uses that font face. You really can't trick out the browser to load that font any earlier. Now, the way Safari works is it hides the fonts until the font face is ready. Whereas some other versions of Firefox would show you a flash of the wrong format and then flash it to the custom format, Safari just hides it. So you can see we use that custom font for a lot of the high priority text information on the page. The Today module uses it, the user's favorites on the side use it, all of our headlines use it. That was bad news. The second problem with using the CSS approach that we talked about a moment ago is browser compatibility. Now, this is a tablet version of the front page. It is built directly for iPads and Android tablet devices. But we don't restrict any user agent from visiting this page. Anyone can visit it. Doesn't matter what user agent they have, we serve them a solid experience. Now, we degrade the experience. We take away controls, we take away CSS formatting from them, CSS visual effects. But in the end, it's still a usable experience. Now, when IA versions less than 9 view our page, they incorrectly parse multiple source properties in the font face block. Now, what happens is they can correctly parse one source, and they assume that that source maybe wraps multiple lines. It goes all the way until it encounters the semicolon. So on your CDN, you'll see a whole load of these really bogus requests. You see, got the medium, a space, another space. So how do we work around this, right? Do we ignore it? No, we can't ignore it. What we did is we went ahead and encoded the true type fonts as a data URI. Now, what's interesting about this is IE9, which can correctly parse multiple formats, doesn't understand either one of these formats and use them alone. IE8, that incorrectly parses the source attribute, but supports data URIs, sees a malformed data URI, and just skips it. Whereas IE7 and IE6, they don't support data URIs. They see a big jumbled URL, and they just skip it altogether. So this lets us hide the error from IE. It just doesn't render the font. Now, the interesting thing here is we use just one data URI. And that's because for SVGs, the font URI, once it's been data encoded, is just too long. Just too long. This is what gives me the angry face as an engineer, because I want clean solutions. I want to be able to just universally encode my fonts and then serve them to the right user agent. That way, we eliminate all that late loading nature of the font and we serve it immediately. So when you encode an SVG document, you use a URI encoded version of the text contents. And for some crazy reason, this is really hard to find on the internet. But, so as you look at it, it's just a standard data URI encoding. You have media type, you have a character set, then you have encoded data. Now, SVG is an XML dialog. It's full of equal signs and double quotes, and angle braces, and spaces, and line returns. All of those characters get encoded. So you take one character that we see visually, and that gets encoded to 2, 3 characters, which blows out the length of this URL an incredible amount. So typically, you can try to mitigate this by subsetting your fonts. Now, subsetting is a technique, if you're not familiar with it, where you take away characters from the font which you're not going to use. For instance, if I'm building a calculator, I'm going to take away most of the letters, I'm going to leave the numbers, and I'll leave a couple of punctuation. You don't need as much punctuation, but you need some of it. So you subset the fonts to include just the characters you want. Unfortunately, Yahoo.com is an international product. Subsetting isn't practical to us. But even if it was, and we could subset the characters to just be punctuation, letters, and numbers, how large is that URI? Well, it's about 30K. Now, if you're familiar with this image from Mozilla, that is the Tiger SVG. I encoded that one using the same approach, and I came out to about 127K. So what's interesting here is we have two SVG files, URI encoded the same way, but one of them is applied to an image source, and one of them is applied to a font face URL. And you want to guess which one works? Not the one we wanted to. Nope. So SVG fonts are fun, right? Lots of fun. It turns out if you keep subsetting this font, keep subsetting it, you can reach a character set that is within the length that is compatible to use as a source attribute. I got it down to about A through Z, upper and lower case. Not an exact K-limit. I invite anyone in this room to find that exact K-limit for me, and let's post it up there and figure out what it is. So we have to very carefully pick when we choose SVG fonts. Now, that's not the only bug. SVG fonts are not friendly to text overflow ellipses. That is one of my best friends. I like text overflow ellipses. I've worked on a lot of properties where you have a fixed DOM element that has a variable length text inside of it. So the two ways you traditionally handle this, it's three ways. One, you truncate it on the server. You pick an arbitrary number of characters and you add ... after it. The second way is you hide overflow, which lets you have infinite levels of the length of text, but the user doesn't get a nice, graceful truncation in that text. The third way, you apply text overflow ellipsis, and the browser determines how large the box is, and then dynamically truncates the text that it displays using an ellipsis, ... So it comes down to something like this. This is what you expect. You have a bunch of blocks floated next to each other, and you want to have a fixed width of the block, but again, the text is variable. Unfortunately, this is not what you get. The browser replaces the text that you expect to see with just ellipses. Ellipsis, is that even the word ellipsis-I? I'm not sure. Ellipsis? Okay. So it replaces it with an ellipsis. So in the end, while designers love font faces, engineers may love font faces, how they look, they have to be implemented carefully. You have to take your time, think hard about it, and do it right. You can't take what's found on the internet and accept it as verbatim and paste it in place and say, it works. Because it may render correctly, it doesn't work the way that we should have our properties work. So, this was probably one of the most interesting things for me while working on this habit. We're handling the viewport. On the desktops, like I said before, we've gotten cozy. The desktops are a dependable size. They're a dependable shape. They're normally 1024, 768 or larger. Heck, all of our layouts now are 974 wide. I remember back when we used to have layouts that were 720 wide, but on 800 by 600 monitors. But now we've gotten cozy. We have wide layouts. Now, the nice thing with these travel devices is users define the orientation that they want in it. They can change position. They can sit on the couch and hold on their lap, narrow, so it's nice and up and down, or they can lie down on their side and turn around the landscape. How do we respond to that? Do we force the user into one layout? Do we let the user scale the device? How do we handle things like fitting the device viewport on different devices? So these are our friends. This is iPad and its ugly brother, step sibling, the Galaxy tablet. And these are about 9.7 inches diagonally, and one's about 7 inches diagonally. So the physical size is interesting. But what gets more interesting is within this physical size, they share the same number of pixels in height. So the same number of pixels in height, different physical size. This creates something that we call PPI, pixels per inch. Now, PPI on the Galaxy is 1/7. So for every inch on the Galaxy, that's a big inch. For every inch on the Galaxy, there are 170 pixels within it. Likewise, the Galaxy tablet, you have 132. But trying to give this some weight. There was research put out there by Microsoft that stated in any touch interface, the info controls need to be at least 5 millimeters in size. They didn't say pixels in size. But what they did go on further to say was users have increased performance, increased ease of use, and more predictable results if they're about 10 millimeters in size. But this time they went on to say 10 millimeters or 40 by 40 pixels. So we just learned that on the Galaxy tab, has the same height, same number of pixels as the taller iPad. So let's figure out what those 40 by 40 pixels actually work out to using PPI, the point squaring from those devices. So 40 by 40 pixels on the iPad is about an 8 millimeter square. Whereas once you take this to the Galaxy tablet, you're now looking at a 6 millimeter square. Can you imagine trying to touch something that's 6 millimeters with your fingertip? It's really infuriating. So this actually hits our product. Is when we try to determine what is an input control. Input controls on desktop devices are easy. We can have an input control that is very, very small because our mouse pointer is about 1 pixel square. It's not hard. Users may not be able to click too easily on those dots down there, but by damn it, they sure can. Now, if we talk about this using a touch interface, trying to click on those dots is very hard because our fingers could overlap multiple dots. Then we leave it up to the browser to determine, did you mean the second dot or the third dot? I'm not really sure. What we create, if we choose input controls that are too small, is an unpredictable user experience. We need to give users experiences which they can depend on, which when they touch it, they know exactly what's going to happen. So for our product, we specifically chose not to make those input controls. So now that we know that pixels change dimension, what else is unique about viewports on tablet devices? And that comes down to their position. For instance, the user, like I said before, can curl up on the couch and have it in one position. They can lie on their side and hold in another position. We want to change the orientation to be responsive to that. And that's called fitting the viewport. And I see I picked a roller coaster for this one. And it's going to get complicated a little bit fast. It's going to start off nice and easy, nice gentle ascent, and then we're going to go straight down the other. When I start posting codes up here, all the slides are available online for you to download. You can see all the code, and you can see my tests. So don't freak out trying to write everything down before I skip the slide. It's all available, it's all accessible. So, to start with, there's a couple terms which we're going to talk about. One, on the bottom here, is device width. In our case, device width is the width of the device in portrait orientation. So the device is a rectangle like this. This is device width. Whereas this is now device height. See that? Now this arrows that are pointing in the opposite directions is for orientation. Tablets can change position. You can change it different directions. That's called changing the orientation. Now this all starts making sense when we start getting into numbers. It also makes sense when we talk about responding to the orientation changes. So when a user on an iPad interacts with Yahoo.com, they're going to see one of two different layouts. If they're in orientation mode, they'll see this first layout. The Today module spans the entire width of the device. The user's favorites, they slide down to make room for the Today module. Now when the same user turns the device the other direction, changes the orientation to landscape, we slide the Today module to the side. And we let the stories, we let the user's favorites slide up. So this is us being responsive and fitting the device to the fullest of its available real estate. Now, doing this is a two-part exercise. The first part is defining the viewport. How big is a viewport? How wide is it? What scale is a viewport? And we do that using a meta viewport tag. This guy is your friend. It's your first line of defense when you're trying to set up a very rich interface that matches the device. And its job, I'll say this slowly, its job is to set a one-to-one mapping between device pixels and CSS pixels. And we do that using a couple arguments. I'll call them arguments. They're inside the content attributes. So we say, first thing that we want our viewport to be is width. We say, browser, make the viewport equal to your device width. So device width, horizontal width on the bottom. That way, the browser doesn't try to size the viewport with content. For instance, if you visit many websites using your iPad or using your mobile device, the browser on that device will try to scale the content, scale the viewport to fit the content, which results in sometimes very, very small text. Sometimes it results in a very unusable interface. The second part is defining the scale. So actually, the second and the third part work together to define the scale. The second part works with your iPads, and it also works on the Android. While the third part, the target density DPI, that works only on the Androids. Now with maximum scale, that's required in order to have a layout which adapts to orientation changes. On the iPad, if you have a layout that's 900 pixels wide, as you change orientation, Mobile Safari will scale your content, will scale the viewport to the maximum available size. So for instance, I have my iPad in my hands here, and it is laying out something that's about 700 pixels wide. If I span it this way, it's going to take that 700 pixel wide block, and it's going to make it bigger. We don't want that. We want to be able to size all of our elements ourselves based on orientation changes. Now the second part's a bit of a black art. Now, on Android devices, the user can go into the browser settings and they can choose a scale level for the page. They can go in there and say, by default, I want my page to be scaled using a far algorithm, or a close algorithm, or a medium algorithm. What this does is it changes the viewport shape again. It changes the scale. So in order for us to fit the viewport, to use a one-to-one mapping between the device pixels and the CSS pixels, we need to constrain the scale in the device width. The width, actually. So once we've defined our viewport size, the next step is to start targeting devices using media queries. Now these are pretty simple. They sound a little crazy in the blogs. We all media query and they throw up a bunch of numbers and a bunch of orientations and you're kind of going, oh crap. But in reality, it breaks down to a couple steps. First you have your at media block. That's the opener on top, at media. Then you define a media type. In our case, we're saying only screen. Now, the only keyword is there to help obscure this media query from older browsers, because at media blocks are not new. We've been able to do that for years. Remember print style sheets? Same thing. But those didn't understand the only keyword. Then we go further and we say device width and orientation. Those are our media features which we're querying for. Once we set up our query, the browser goes ahead and applies any styles that are within the curly braces. So it's really easy on the iPad. Like I said, remember, gentle ascent. The iPad is easy. Its device width is always 768 pixels. This width here is always 768. So when you build your media queries, that is a constant for you to work with. So here we are. The iPad and portrait is easy to target. You say, we know your device width is going to be 768 pixels. And if we want to target you in portrait orientation, go in the iPad. Now likewise, to get to the landscape, you just change orientation value from portrait to landscape. And it's a win. Now, if you're building a site that you can depend on only being viewed on iPads, I'll be honest with you, this is as far as you have to go. My presentation's done, you can go home, you can work on all your stuff. But we build websites that are where the consumer is. We build websites that can be used on multiple devices. It's important for our content to be open. So we support the Galaxy tab also. For better and sometimes I think for worse. So let me get into this. The Galaxy tab doesn't have a constant device width like the iPad does. Its device width changes based on orientation. Oops, go back. Not done with you yet. So we notice here, it's either 600 pixels wide or it's 1024. Now that's the size of the viewport on the Galaxy tab, remember? 600 by 1024. Now, the fact that the device width changes based on orientation may be okay, because that's 600 there, that's 1024, and they are both width at that point. It's width relative to the user. That makes sense. I can let that one go. Unfortunately, on the Galaxy tab, device height is also a little bit funky. Now, the device doesn't change height. It's always the same pixel height. But when you open up the virtual keyboard on the Galaxy tab, the device changes height. It says, now my device height is no longer a predictable amount. It has changed. So what's actually happening here is the Galaxy tab gets confused about some things. It confuses the size of the viewport in the browser to be the size of the screen. Now, if you opened up Firefox and you typed in screen.width, it'll tell you the size of your monitor. It'd be 1440 by 900 or whatever your desktop resolution is. If you typed in window.inner height, or inner width for that matter, to keep things consistent, that will tell you the size of the viewport, the size of the document that's inside the browser. That's exactly what we're seeing here. The Galaxy tab subtracts things like the browser Chrome. It subtracts other elements like the virtual keyboard from the overall device height, which gives you a really screwy thing to try to lay out. And fortunately, it gets even more broken. And it makes me think, I'm building out this interface, and it's still kind of new to me. I built the iPad site, and I've done a lot of reading, a lot of tests, but these kind of bugs I'm seeing make me wonder, am I doing something wrong? So I start building a lot of standalone tests, and I start showing them to people, and they say, no, these are crappy browser bugs. And this one is probably my favorite one. Now, I'll take a drink of water, and you can read it, then I'll explain this to you. So if you opened your desktop browser, you added two media queries. You added a media query for a landscape orientation and a media query for a portrait orientation. Then you resized your browser window. When your browser window was more narrow than it is wide, it's going to match that portrait orientation, because your browser is a narrow, tall box. If you changed it to be wider than it is tall, the browser, your desktop browser, will match a media query for landscape. I understand that makes sense. But unfortunately, when you open the virtual keyboard on the Galaxy tablet, it's going to make a browser, the inner height of the viewport is going to be shorter than it is wide, and it's going to trigger a landscape media query. So if you have two different layouts, you have a layout for portrait and a layout for landscape, the moment you open the virtual keyboard, the device is going to be helpful, and it's going to switch your layout to landscape, and it's going to go crazy, and the keyboard closes, and you might be getting a lot of bugs and a lot of pissed off users. So if your website doesn't ever have any text input boxes on it, that won't affect you. But nearly every website at Yahoo is going to have at least one search box on it. So that means any website at Yahoo that wants to target Galaxy tablets can never, ever rely on orientation. The Galaxy tablet's orientation is broken, just flat out broken. One thing you can rely on are the widths. The device width is always consistent. We saw that device height is broken. We saw that orientation is broken. Device width is consistent. But the Galaxy tab is still not a great device for what we need to do. What happens is, if you define these bottom two media queries, and you stop there, page load will be okay. The browser will intelligently pick the correct media query on page load. But as you turn the device, it will not re-query. It will not pick now the new media query. The way to make that fixed is by adding at least one orientation media query to your document. It doesn't even have to do anything. It just has to be there. Completely broken. So we see these crazy bugs, and we wonder, why the heck am I doing this, right? It must have been about 3 days trying to debug the Galaxy tablet, and during that time, I think every one of my CubeMates got it left at some point during the day. So I was vocal, I was mad, I was that bombs were dropping here, and that expletives over there. But in the end, that's the price we pay for dealing with these very fast-moving front-end development environments. And we say that front-end web development moves fast, right? It moves fast, but it doesn't really. Some browsers move fast. But luckily for us, those browsers are browsers which we have to target in mobile devices. So for us, mobile devices and mobile front-end development moves even faster. It moves very, very quickly, which means that you're going to have some things that work, like the iPad. iPad's great. And you have some things that don't work at all, like the Galaxy tablet. But you have to be very, very, very gentle and to tread lightly. Now, remember we launched this just in time for the holiday season. We pushed hard, we got it done in just a couple weeks. And it was a really quiet PR launch. There was no press release. There was no yodel, anecdotal stuff. We just launched it. It was skunkworks. We got it out there. And the funny thing happened is people actually liked it. And we spent so much time hearing bad vibes on the internet about Yahoo. Like, oh, Yahoo this, Yahoo that. And I felt really proud about this. I said, finally, we have a product that users are using on their own, they're enjoying, and they're telling their friends. And once I started reading this, I really got the idea that this was a good thing to support. more devices are good, more users are good. Be there with them. So the takeaway from our presentation is stuff's rough, but I think we should all buckle up and just go ahead and get on. Now, all the notes and Galaxy tests I spoke about are available for download, and the SlideShare document is also there for us to actually view this in your own time. So that's all I got for you today. Hope it worked out well.
Have you given any thought to, or I guess you probably did, so I'm wondering why did you choose to put it as /tablet versus just detecting it and switching it automatically and giving the user an option to switch back to the non-tablet if they want?
I'm really happy you asked. So what we do is when users, let me re-ask the question. So the question was, why do we have a URL that ends with tablet? Yahoo.com/tablet. Not just Yahoo.com, that serves the correct response. And the answer, let me back up and tell you a little bit how we handle user agents, and then I'll tell you the answer to your direct question. User agents that match an iPad or match a Galaxy tablet, we redirect directly to Yahoo.com/tablet. Now, once users are there, there's a link on the bottom of the page that will take them back to Yahoo.com, take them back to the desktop version. At that point, we set a cookie so that we don't redirect the user again. So we give users an out. The reason why we chose /tablet was to leave ourselves open in the future for using the application cache, for using manifests. Now, once you attach a manifest to your page and you say, my page is available offline, it caches the page response. So if we had opened this up and said, Yahoo.com will serve just iPad, will serve iPad and desktop, then the user would always see the iPad response, even if we fed them desktop data. So we kept it separated into its own URL so that we can give it a manifest and make it available offline.
Does the maximum scale equal 1 access?
So what it does is it does disable users to pinch to scale themselves. So in that regard, it makes it more challenging to use because we have to ensure that the text we have will suffice for a majority of our users. It's required to use a maximum scale in order to have an orientation responsive layout. So it's a trade-off. You can choose to fit the orientation, or you can choose to allow scale, but not both. With that said, we're not locked into always one fixed font size. Something which we're working on the front end is still catching those zoom events, catching those pinch events in JavaScript, and changing our body font size to allow, because we use M's for all of our font size. We do, I'm sure you all do too. So as the user zooms out, we can increase our body font size, thereby increasing the relative font size of all the text within our document, still giving the user the ability to increase the font size to be more legible, but still retain the ability for us to match the orientation of the device with a perfect fit layout. Mark.
When you open up the keyboard on the Galaxy tab, does it give you a window resize of it? Not that that should be used to solve, and not that that's not a true bug, but
so curious. From what I remember, we get a orientation change event when they open it in portrait. When user opens it in, not resize, but when user opens it in landscape, of course, you don't get the orientation event. I don't remember if we get a resize event. That's an excellent thing, because we're ultimately, front-end development is a game where you're hunting ducks and you're trying to squash squirrels, and you need to find just a little hook to try to tie into something. So I'm definitely going to check that out later.
I do mobile development for phones, and I've noticed that Android, it seems that when you change orientation in Android, it also incorrectly reports the device width and device height. In other words, it reports what it was, not what it is.
Mm-hmm.
Have you noticed that bug and developed any kind of a workaround or
That's a great question.
normalization for Android devices?
So something which I noticed is along the same lines when we access the screen size. So if we access what we hope is device.width and device height, not device width and device height, we can access that through the screen property, right? Screen object. If we access that too soon, say the user changes orientation, and if we access that directly from the orientation change event, we get really crazy results. We get numbers that are too big or too small. If I waited a second and then accessed it, it was always correct. That was one area which I found. there's also this other bug which I didn't talk about here, but what's interesting is going from one property to another. You go from property A to property B. When you leave property A to go to property B, the Galaxy tab will resize the viewport. Say we're going from Yahoo tablet front page to Yahoo News, which is a desktop property. So the width for that viewport ultimately is going to be about 1,000 pixels wide. It's going to be 974. When the user clicks back, if our JavaScript starts running again, then it'll actually report the device width for the previous site. So now we're back on site A, and I'm getting this guy's device width. So it's cat and mouse. I don't have any perfect workarounds, but once we stop trying to access things immediately, we got more predictable results, especially as we open up keyboard trays and such. Yeah, just real mess. Real mess. What's interesting is that portrait orientation bug I talked about, where when you open up the keyboard, it changes orientation for you. And some of the other ones, I wasn't able to replicate on a Galaxy S phone running Android 2.1. It was just 2.2 on the Galaxy tab that was really hit or miss when dealing with the viewport properties.
You said that these were kind of hard to find online. There wasn't much information. Have you tried submitting those tickets upstream?
No, not yet. I just made the reproducible test cases over the weekend. So, I wanted them there and testable, and I want to get some other eyes on them before I do that.
It's a long job, but it's probably
It is, and the thing that really blows my mind is that these are devices which have been released to consumers, right? It's not like it can be updated on the fly very easily. The person has to say, yes, go ahead and update my operating system. To get these fixed is going to take a long time. And even then, we're going to have to be okay with some users getting broken experiences when they haven't updated their devices. So it's I was stunned that Samsung would release it like this. The one thing I could really use help with is if anyone else out here has Galaxy devices that run Android 2.2, check out the test that I posted over here. See if you can recreate the same results I found. At least that would make me feel good that what we're seeing are Galaxy tab bugs, not just bugs in the Android browser implementation.
So I answered the previous question about the resize event. If you wait for the, so I think what we found was the event sequence. So if you wait for the orientation, they give you the wrong type. But if you wait for the resize event, then it will give you the right dimension. So we disable the orientation, so we just wait for the resize event to happen to get the correct.
I suppose this may because resize the orientation didn't change, and you might be able to cancel it.
Awesome. Yeah.
I'm curious about detail on the image loading implementation. Why did you choose to use a data attribute instead of setting background none in CSS and just removing that CSS rule in JavaScript versus having to actually set the style background in JavaScript, not just having that set ahead of time?
It's an interesting idea. It wasn't a conscious decision. The use of the data attributes, just the data type and naming, was purely to make myself feel good about having a custom attribute in there. The ability to remove a background, just remove a style that would pretty much mute the background image, I didn't consider that, but that is simpler. So I like that idea a lot. Thanks, Steve.
And not my idea.
Well, I like the idea. Where was that idea?
Why my image loader?
Nice. Are there any more questions? All right. So, please. Great question. So this year, I think we're looking at 2 more Samsung tablets. We have an HP tablet out there running a different OS. We have a BlackBerry Playbook, which is same size as the Galaxy tablet. And we also have the Zoom. We are supporting these slowly. And the reason why is because we want to test them through. Now, resolution-wise, we're looking at about 3 main sizes. We have the Samsung and the Playbook, which are 1024 or 600 by 1024. We have the iPad, which is 768 by 1024. Then we have the Zoom, which I believe is 800 by 1280. So what's interesting is the Galaxy the Galaxy 10.1 tablet is the same pixel dimensions as the Zoom. The Playbook from HP is the same pixel dimensions as the iPad. No, the touchpad from HP is the same pixel dimensions as the iPad. And the Playbook from BlackBerry is the same pixel dimensions as the Galaxy. So our idea, we haven't been able to vet this out yet, is support classes of resolutions. And then once we can support those classes, then get the devices and test the devices within that class. Things like emulators don't suffice for testing. For instance, if we went out and pulled down the Motorola Zoom emulator, what it actually is just a skin around a standard Zoom, a standard Android emulation. So with emulators, you get something which is sometimes right, sometimes wrong, normally slow, and generally, I would never ever put a site out there that I didn't touch myself on a physical device. It's the only way that you get a good idea if the controls are the right size due to PPI differences, if your implementation is actually performing well within the constraints of the device and hardware acceleration. It's tricky to support multiple devices. And it's something that the mobile group learned a long time ago is to do it right, you need a ton of devices. You need a ton of all the classes with the different firmware versions, and you need to test them every release. So we have to tread slowly. Tablets are expensive, and it's expensive time-wise to test on them also. So we are looking to pick up one large tablet this year, the Zoom or the Galaxy 1021. We haven't had a chance to do that yet. All right.
All right, then.